First and foremost, I would like to thank Department of Physics, Namchi Government College and Sikkim University for providing us this platform to make this topic common emitter amplifier. I would also like to thank our respected Sir Dr. C.P. Khateora for the partial fulfillment of BSc 3rd semester June to December 2020. My name is Poonam Chhetri and roll number is 19NS0147 and my topic is common emitter amplifier. So first we are going to talk about amplifier, how it works and its types. Amplifier is a device which increases the voltage and power level. When we apply input signal in amplifier, the voltage and power level of amplifier increases and gives us output signal. If the sinusoidal is giving a signal, the increase in voltage and power level gives us sinusoidal voltage. This is called amplifier. Now type of amplifier. There is two type of amplifier. One is single stage amplifier and multi-stage amplifier. Now single stage amplifier. Topic itself says that it will only have single stage and only one transistor is used. You can see in this figure there is only one transistor. This part of the circuit is called divider biasing circuit. Now, अब यो डिवाइडर बाइसिङ सर्किटको काम चाहिँ के हो भन्दाखेरि चाहिँ यो जुन ट्रान्जिस्टर छ त्यसको अपरेटिङ पोइन्टलाई चाहिँ सिप हुनु दिँदैन, किनकि डिवाइडर चाहिँ के हो भन्दाखेरि चाहिँ बाइसिङ छ। यो इनपुटको ठाउँमा हामीले एसी सिग्नल दिन्छ अनि एसी सिग्नललाई एम्प्लिफाई गर्दा हामीले आउटपुट सिग्नल पाइन्छ। यो सीसी मतलब कपलिङ क्यापेसिटर त्यसले चाहिँ के गर्छ भन्दाखेरि चाहिँ यहाँबाट जुन चाहिँ एसी सिग्नल पास हुँदैछ नि त्यसलाई चाहिँ एसी सिग्नललाई चाहिँ पास गर्छ अनि डीसी सिग्नललाई ब्लक गर्छ। मतलब भन्नु खोज्दाखेरि चाहिँ अब के हो भन्दाखेरि चाहिँ अब यहाँबाट त हामीले एसी मात्रै पठाएको छ, डीसी कसरी ब्लक गर्छ भन्दाखेरि जब हामीले यहाँबाट एसी पास गर्छ नि यो यहाँबाट, अन्त एसी सँगसँगै चाहिँ डीसी पनि अलिकति न अलिकति चाहिँ गएको हुन्छ। त्यही कारणले चाहिँ यो सीसी को काम चाहिँ के हो भन्दाखेरि चाहिँ एसीलाई पास गर्नु, डीसीलाई ब्लक गर्नु। सिमिलरली यो सीसी पनि त्यही हो, कपलिङ क्यापेसिटर नै हो, यसले पनि त्यही हो, एसी छिर्नु दिन्छ, एसीलाई पास गरिदिन्छ, डीसीलाई ब्लक। अन्त यसमा यो आरी छ नि, यो आरी भनेको चाहिँ एमिटर रेजिस्टर हो। अनि यो जुन ट्रान्जिस्टर छ त्यसको वान साइड एउटा बेस हुन्छ, एउटा कलेक्टर अनि एउटा एम्पिटर हुन्छ। यो आरसी भनेको यो आरसी भनेको चाहिँ कलेक्टर रेजिस्टर हो। अनि यो सर्किट बाइसिङ डिभाइडर बाइसिङ सर्किट हुनको कारणले चाहिँ बाइसिङको लागि चाहिँ के छ भन्दाखेरि चाहिँ VCC लगाएको हुन्छ। यो CE चाहिँ के हो? अब यो CE चाहिँ के हो भन्दाखेरि चाहिँ यो चाहिँ CE चाहिँ क्यापेसिटर हो। यो CE को पनि सेम यो CC को यो दुईटा CC को जस्तै काम हो। AC सिग्नललाई पास गर्नु, DC सिग्नललाई प्लग गर्नु। अनि के हुन्छ भन्दाखेरि यहाँनिर जुन चाहिँ पनि AC सिग्नल पास भएको छ नि त्यो चाहिँ फ्लो भएर चाहिँ यहाँनिर पुग्छ। अनि यहाँको AC चाहिँ यो RL मतलब त्यो रको जुन चाहिँ AC हुन्छ नि हो त्यो चाहिँ यो RL मा पुग्छ हैन। अनि यो RL मा पुग्दाखेरि चाहिँ के हुन्छ भन्दाखेरि चाहिँ नि हामीले आउटपुट सिग्नल पाउँछ। अनि यो आउटपुट सिग्नल चाहिँ नि अब AC त अब उयो एम्प्लिफाई भएर आएको हो नि त। अनि यो एम्प्लिफायरको कामै के हो भन्दाखेरि चाहिँ उयो के रे उयो भोल्टेज र पावर लेभल इन्क्रिज गर्नु हो। त्यही कारण यो आउटपुट सिग्नलमा जुन चाहिँ भोल्टेज र पावर लेभल छ त्यो चाहिँ इन्क्रिज भएर नै आएको हुन्छ। यसलाई नै के भन्छ भन्दाखेरि चाहिँ सिंगल स्टेज एम्प्लिफायर भन्छ। मल्टी स्टेज एम्प्लिफायर यो एउटा एम्प्लिफायर हो अनि यो अर्को एम्प्लिफायर। यो दुईटा एम्प्लिफायरलाई जोड्नुको लागि हामीले एउटा डिभाइस युज गरेको हुन्छ। त्यो डिभाइसलाई कप्लिङ डिभाइस भनिन्छ। मल्टी स्टेज भनेको नै यही हो कि एउटा स्टेज सिंगल स्टेज एम्प्लिफायर अर्को सिंगल स्टेज एम्प्लिफायरलाई कम्बाइन गरेर मल्टी स्टेज एम्प्लिफायर हुन्छ। यो दुईटा एम्प्लिफायरलाई जोइन गर्ने प्रोसेसलाई क्यास्केडिङ भनिन्छ। अब बेसिक पर्पज अफ कप्लिङ डिभाइस basic purpose of coupling device. Basic purpose of coupling device is number 1 to transfer the AC from the output of one stage to the input of next stage. Number 2 purpose of coupling device is to block the DC to pass from the output of one stage to the input of next stage, which means to isolate the DC condition. Common emitter amplifier. In electronics, a common emitter amplifier is one of the basic single-stage bipolar junction transistor (BJT) amplifier. In this circuit, the base terminal of the transistor services as the input and the collector is the output, and emitter is common to both. Emitter degeneration. Common emitter amplifiers gives the amplifier an inverted output and can have a very high gain that may vary widely from one transistor to the next. The gain is a strong function of both temperature and bias current, and so the actual gain is somewhat unpredictable. Stability is another problem associated with such high gain circuits due to any unintentional positive feedback that may be present. Other problems, there is another problem, and that problem is the circuit at the low input dynamic range imposed by the small signal limit. There is high distortion if this limit is exceeded and the transistor chooses to behave like its small signal model. One common way of elaborating this issue is with emitter degeneration. This refers to the additions of a small resistor between the emitter and common signal source. Bandwidth of the CE amplifier tends to be low due to high capacitance resulting from Miller effect. The parasitic base collector capacitance CCB appears like a large parasitance capacitor CCB 1 minus AV, where AV is negative from the base to ground. This large capacitor greatly decreases the bandwidth of the amplifier as it makes the time constant of the parasitic input RC, where RS 1 minus AV, CCB, where RS is the output impedance of the signal source connected to the idle base. There can be many problems in several ways, including number one problem is reduction of the voltage gain magnitude AV example by using emitter degeneration. And second problem is reduction of the output impedance RS of the signal source connected to the base. For example, by using an emitter followers of same order voltage followers. Next is using a cascade configuration which insert a low input impedance current buffer. Example, a common base amplifier. Between the transistor's collector and the load. This configuration holds the transistor's collector voltage roughly constant, thus making the base to collector gain 0 and ideally removing the Miller effect. Number 4 problem, using a differential amplifier. An emitter follows driving a grounded base amplifier. As long as the emitter follows as long as the emitter followers is truly a common collector amplifier, the Miller effect is removed. Miller effect. Miller effect negatively affect the performance of the common source amplifier in the same way. When an AC signal is applied to the transistor amplifier, it causes the base voltage VB to fluctuate in value at the AC signal. And the positive half of the applied signal will cause an increase in the value of VB. This turn will increase in emitter current and collector current IC. As a result, the collector emitter voltage will be reduced because of the increased voltage drop across RL. The decrease in IB, this action then causes a corresponding decreases in IE through RL. It is also named common emitter amplifier because the emitter of the transistor is common to both the input circuit and output circuit. The input signal is applied across the ground and the collector of the transistor. Since the emitter is connected to the ground, it is common to signal input and output. The common emitter circuit is the most widely used of junction transistor amplifiers. As compared with the common base connection, it has higher input independence and lower output independence. A signal power supply is easily used for biasing. In addition, higher voltage and power gains are usually obtained for common emitter operation. Current gain in the common emitter current circuit is obtained from the base and the collector circuit current. Because a very small change in base current produces a large change in collector current, the current gain is always greater than unity for the common emitter circuit. A typical value is about 50. Now, where does common emitter amplifier is used? Common emitter amplifier are also used in radio frequency circuit. For example, to amplify faint signal received by an antenna. In this case, it is common to replace the load resistor with a turned circuit. This may be done to limit the bandwidth to a narrow band centered around the intended operations frequency. More importantly, it also allows the circuit can be used to resonate any inter electrodes and stray capacitance which normally limit the frequency response. Common emitters are also commonly used as low noise amplifier.